Lesson 4.3 is the equation of lines and different forms of the equation of lines. So first I would pause the video and write down these notes. So first, there's three different types of equations of a line. The first one is standard form, ax plus by plus d is equal to 0. Normally we want a, b, and d to be integers, so not fractions or decimals. Gradient or slope-intercept form of the line, y equals mx plus c, where m is your slope and c is your y-intercept. And point gradient or slope form, where you have y minus a y-coordinate is equal to your slope times x minus an x-coordinate. So x1, y1 is any coordinate point on the graph. Just make sure they come from the same coordinate pair. And then from previous notes, you have your slope formula, which is your change in y over change in x, y2 minus y1 over x2 minus x1. Your x-intercept is where your graph intersects the x-axis, or where your y-coordinate is equal to 0. And your y-intercept is where the graph intersects the y-axis, or where your x-coordinate is equal to 0. So try these two examples. The first one, you're writing the equation of the line in point gradient form that has a gradient of 3 and passes through the point A, which is at 1, 7, and also sketch a graph of the line. And for number 2, find the equation of the line in gradient intercept form that passes through the points 1, 3, and 2, 5, and also sketch a graph. So go ahead and pause the video and try these two. So for the first one, very straightforward. They give us a point and they give us our gradient. So point gradient, just plug it in. Y minus your y coordinate of 7 is equal to your slope of 3 times x minus your x coordinate of 1. So if you haven't already done so, go ahead and pause the video and do number 2. So we're given 2 points. The first thing I did is I found the slope between them. So I used slope formula, change in y over change in x, and got the slope to be 2. And then I took the gradient, or the slope, and point A, and I plugged it into point slope form of the line, and I did y minus 3 is equal to 2x minus 1, but they want it in gradient intercept form, which is y equals mx plus c. So then I just solved for y, so I distributed the 2 through and added 3 to both sides, and got y is equal to 2x plus 1. For the graphs of these two, for the first one, I graphed the point 1, 7, and then it has a slope of 3, so I just went up 3 over 1, so there's the sketch of that line. And then for this one, I graphed the y-intercept of 1 and a slope of 2, so up 2 over 1, and that's the graph of the second line. So here's another example. Points A and B are on the straight line boundary of 2 plots of land here, and we want to write an equation of the line that passes through A and B. And then we also have a tree that's at point C, which is 25, 30, and we want to decide whether or not the tree is on the boundary line. So write the equation of the line that passes through points A and B, and then decide whether or not C is also on that line. So go ahead and pause the video and try that. So first thing I did was I found the coordinates of A and B. So the coordinate of A is 6, 8, and the coordinate of B is 12, 10. And then I found the slope between them, so I found the slope to be 1/3. So then you didn't have to have all 3 of these answers, but either point slope form using either the 2 points, or slope intercept form, either solving this one for slope intercept form or seeing the y-intercept here at 6. So one of these 3 forms of the line is the equation of the line. So then to test whether or not the tree is on the line or not, I just plugged in the point 25, 30 for x and y into one form of the equation. I just did this first one here. And I got that 22 was equal to 19 over 3, which is not true. So therefore, the tree is not on our boundary line. For the next one, we have 2 straight rows with equations y equals 3x plus 15 and y equals negative 2x plus 5. We need to install a traffic light at their intersection point. So we need to find the coordinates of the intersection point. So go ahead and pause the video and find the intersection of these 2 lines. Because these are both solved for y, this is set up pretty nicely for substitution method, so I just set the 2 equations equal to each other and solved for x. So 3x plus 15 equals negative 2x plus 5. I added 2x and subtracted 15 from both sides, divided both sides by 5, and you end up with x to be negative 2. And then because this is where both of them intersect, it doesn't matter which equation you plug the negative 2 back into to solve for y. So I just plugged it into the first equation, and I got y is equal to 3 times negative 2 plus 15. So y is equal to 9. So the place where these 2 rows intersect is at the coordinate point negative 2, 9. Next example, a straight country road with equation y equals negative 0.75x plus 11.5 intersects 2 state highways with equations x equals 0 and y equals 0. A beverage shop owner wants to open 2 new shops exactly at the intersections of the country road with the state highways. So go ahead and pause the video and sketch a graph of the line representing the country road. So here I graph the 2 state highways, y equals 0 and x equals 0, and then I graph the line y equals negative 0.5x plus 11.5, so it had a y-intercept 11.5 and then a slope of negative 3/4, so I went down 3/4, and this is what the line looks like. So the beverage shop wants to open 2 new shops at the 2 intersection points, so it wants to open a shop here and here. So we want to find the exact location of those 2 shops and then find the distance between them. So go ahead and pause the video and find the exact location of those 2 shops and the distance between them. So I found the x and y intercepts because that's the intersection with x equals 0 and y equals 0. So my x-intercept is where it intersects the x-axis, or y equals 0. So I plugged in 0 for y. And then I moved the negative 0.75x to both sides, divided both sides by 0.75, and got x to be 15.3. So our x-intercept is 15.3, 0. And then where it intersects x equals 0, that would be your y-intercept, which you could probably just read straight off of this slope-intercept form, or plug in 0 for x, negative 0.75 times 0 is 0, plus 11.5 would be 11.5. So where the second beverage shop should be at 0, 11.5. So now you have 2 coordinate points, 15.3, 0 and 0, 11.5. So then I used distance formula to find the distance between them and got 19.2. They don't give us any units, so that's just 19.2. In this last example, Brook Lake Town had only 50 social housing units when the new social program started. Since then, it has been adding social housing units at a steady rate. Now, 17 years later, the town has a total of 322 social housing units. So since it's a steady rate, that's the same thing as constant rate, so this can be represented linearly. So given that information, go ahead and answer all these questions A through H. So for parts A and B, I found out what the rate of increase was by finding how much it had increased, how many houses had increased. So there was 272 new houses over the 17 years, so they're averaging 16 new houses per year. So then for our equation here, you're going to have the number of houses equal to 16 times how many every years plus the 50 that we started with. So if you haven't already done so, go ahead and pause the video and finish parts C through H. So for part C, we wanted to graph the equation, so I have that down here. I have my x-axis to be years, and I have my y-axis to be houses, and it's increasing by 16 houses per year. And then for part D, it asks us for the gradient. That's the same thing as the rate of increase, so it's going to be 16, and what it means is for every year you increase, the number of houses is going to increase by 16. Part E is asking for the y-intercept, so that would be C, which is 50. So this is saying when the program started at year 0, there would be 50 houses. For part F, determine how many social housing units there will be after 13 years. So years is x, so I plugged in 13 for x. 16 times 13 plus 50, there were 258 houses after 13 years. And then part G, it says predict the number of social housing units there will be after 22 years. So again, same thing, I plugged in 22 for x. 16 times 22 plus 50 is 402. State any assumptions, so this is assuming the rate stays constant because it's after what we're looking at. So we're predicting the future because right now we're only at year 17, so we have to assume that nothing changes. And then for the last one, it says determine the year in which the town will add its 200th social housing unit after the program will be added. So now houses is H, so I plugged in 200 for H and solved for X, and you end up with X to be 9.375, so after the 9th year or during the 10th year, they'll add the 200th house. So this has been equations of lines, the different forms of equations of lines, and their applications.